All right. So the tectonic plates of the Earth, um, as we've seen, are moving. And those tectonic plates, there's about 12 major ones, um, form the surface of the Earth and the oceans. And we can call this tectonics notes. Tectonics notes. So really, the idea that the plates of the Earth are moving goes back to Alfred Wegener, as it talked about in your book, the German scientist who first proposed the idea of continental drift. It was a pretty major undertaking, and he was ridiculed in a lot of geological circles because his ideas were so outrageous. It turns out that he was correct. But the reasons for the plates moving, it goes back 14 billion years ago, really, to the formation of the solar system. In the beginning of the solar system, our solar system was a ball of dust and gas. Starting from the Big Bang. In the second stage of this, it's often called the concretionary stage. Concretion. You should be writing this down. Concretionary stage. Though the dust and gas started to join together because of gravity. Gravity pulled together the particles of dust and gas, and bigger groups of stuff started to form, called planetesimals. Planetesimal. A planetesimal is like a baby planet. And so as time moved forward, our modern solar system formed. And our modern solar system, of course, has different planets at different points in orbit around a central sun. So here's a few of them: Mercury, Venus, Earth, Mars. So this is Earth here. Mercury, Venus, Earth, Mars. So if we look, and this of course is the sun. Now the sun really is a factory for fusion. Fusion on the sun, where hydrogen is fusing with other hydrogen molecules to form helium. They're coming together and joining together to form heavier elements. And there's a certain amount of radiation that's given off. Radiation. There's also, and this gets to our story here, there's also leftover radiation in the core of our own Earth. So this is the Earth. And that leftover radiation is left over from the Big Bang. So this is the core, and it has leftover radiation from the origin of our solar system. Okay, so that leftover radiation that's inside the Earth, in the core of the Earth, let's take a look at this. That leftover radiation has one property that's really important. Katie?
What is the Big Bang?
The Big Bang is what scientists hypothesize as the beginning of our solar system, when all the matter in our solar system was condensed into a small space, super small, and it became unstable, it exploded, and it formed all of the known elements that we have now and all the known material in our universe. We're not sure. So this radiation on the inside of the Earth, one of the properties or byproducts of radiation is that radiation gives off heat. Gives off heat. Okay. So this radiation on the inside of the Earth, here's the core again, and we'll draw the mantle. Wow, that's really bad. So there's the mantle. Now, one of the things that we talked about heat doing is that what does the heat do? What does the heat do to the mantle? Yeah. Causes convection currents, but how? How does it cause convection currents? Dominic.
Because the heat from the core, when it heats up the liquid, the hot liquid rises up because it has less density as the cooler liquid, and then once the hot liquid reaches closer to the crust, it cools down and the cycle repeats over and over.
Good. So the main thing is that this heat decreases density of the mantle rock so it decreases the density of the mantle rock. If it decreases the density, the mantle rock rises. So the mantle rises. So here, let's show a picture of that. Here's the mantle rock. It's near the core. It's hotter there, and it decreases in density because it's increasing in volume. So it goes from mantle rock. If you looked at the molecules of the mantle rock, when it's cold, it would look like this, very dense. So this is mantle cold. This is mantle warm, or hot really. All the molecules are spread out. And because the volume increases of that rock, when things get hot, they increase in volume. When it does that, it rises up, kind of like a cork floating on water. Well, when it rises, it creates convection currents. Convection currents. And getting now to our crust that's on top of the mantle. Here's the crust with the continents and the oceans. And that crust is divided up into plates separated by cracks. When that convection current hits this crustal plate, it moves it. The convection currents, in the mantle moves the plates. And that's really the reason why these giant crustal plates, all 12 of them, actually a little bit more, 12 major ones, are moving. It's because there's leftover radiation from the formation of our universe. And that's the main reason. Okay? Does that make sense? Okay. All right, let's field some questions now. Let's stop this. And